here, has another x-intercept, and then takes off.
So there's a global minimum somewhere down there?
There is, yes, this one would have a global minimum. In this, yes, in this class though, I'll put the rest of this here because it does belong there, okay? In this class,
Not quite as long as it looked like it was.
what we're going to be able to find, we need to be able to find the x-intercepts. That absolutely we have to be able to do. We also have to be able to tell what's happening on the left and right. So we have to be able to determine that the left and right hand sides are going up or down. We'll have to figure that out. We also will need to be able to find in this class where the function is positive and negative. What do I mean by that?
Where it's rising, where it's falling.
That's increasing, decreasing.
Where it's below the x-axis and above.
I need to know where this function is above, below, above, right? I need to be able to do that. You need to be able to do that, yes? The questions we will not answer in this class, okay, are where this local max is, where this global minimum is, where it's increasing and where it's decreasing. We will not be able to do in this class. You will do that in calculus, but not in here. So in a Cal 1 class, you walk in and they assume you can find the x-intercepts and have a general picture of, or general idea of what the picture looks like, and then you start to go after these points in Cal 1. Understand? So our goal is to just get a pretty good sketch of what's going on here. All right? You with me? All right, but notice also, this is what I refer to as smooth and curved. Like if you draw that thing, it doesn't have any jagged edges on it, right? I'm going to change it. I'm going to make it, let's make it a degree 4 polynomial. And let me change some of these things. We look at this one. Goes up on the left, comes down, x-intercept, right? Notice that it crosses through the x-axis there, right? Then it comes down a little bit, comes back up, and then what does it do right there? It touches at the origin, right? And then comes back down, right? So does it actually cross through the x-axis there? Does it look like it does?
You can't really tell.
You can't tell, but it doesn't look like it does, right? Maybe I'll, yeah, that's zoomed in. That's zoomed in a little more.
It does. It looks like it barely touches.
It just touches at maybe one point and then comes back down. That's actually what's happening. So
Right at zero.
compare this left side. Hold on. Compare this left side. We come down. It crosses through the x-axis, right? We come back down, go back up, and then here we don't cross through to the other side. We actually just touch and come back. So I'm going to refer to that in two different ways, and I'm going to let y'all decide what you like best. That function is coming up, and it is bouncing off the x-axis, or do you want to say it's just touching the x-axis? What makes more sense to you?
Yeah, zero,
Touching?
zero, it just touches.
Touching?
I don't like the term bounds.
I'll use them both, okay? But y'all understand what I mean?
Yeah.
Yes?
Just kind of taps the line and then gets back down.
And we will use that. And we're going to be able to figure out where our function does this. So we need to get used to that language. Let me give you a degree 3 polynomial. Tell me if you can tell what the major difference is on this one.
It's going through the x-axis.
It does go through, yes.
It has two curves.
It has two little curves, right? What about the left side? Where does the left side going? Down. Where's the right side going? Up, right? What if I change it to a 5th degree polynomial? Look at left side's going down, right side's going up.
So evens, they both go up or they both go down.
Something like that, yeah. We're gonna have a summary of this, but do you see that the characteristics there changed?
Evens, they go in the same direction.
Okay, let's talk about the end behavior, which is what we're referring to right now. As x gets really big and positive, in other words, if you're looking at the graph of a polynomial function and you're going to let x go out to infinity, so you're going out to infinity on your graph, and you want to know, does the graph go up or does the graph go down, right? This is called, in this case, this is called the right end behavior. Right end either goes up or right end either goes down. If you instead go out the other way to negative infinity, your graph can either go up or it can go down. And that's called the left end behavior. All right? The way that a polynomial will behave, okay, the way it will behave will always be similar to what this part of it does. Now, do you recognize from a polynomial function what this is? The highest power of x
The degree.
and the leading coefficient, right?
Yeah.
Whatever this piece does is what the entire graph should do. So let me try and explain this with an example. If I have 5x to the fourth plus, and then a bunch of other junk in here, and I tell you this is the highest power of x, and then a bunch of other stuff here, how does this behave? Well, how does x to the fourth behave? Like even, so both sides go up, right? And then a positive number in front
Stretch.
just stretches it out, right? What if I put a negative 5 here?
It's going to go both go down.
Then it would both go down, right? Both sides would go down. So all the information that we need about the left and right behavior of a polynomial function comes from just knowing this piece right here. Which leads us to something really nice, which is called, well, yeah, it's called the leading coefficient test. And it's that table right there. So I'm going to write, to determine left and right behavior of a polynomial, I'm just going to put poly function, use the leading coefficient test. Which I'll refer to as LCT from here on out. And it's that table right there. Even. Now, you can memorize this table or you can just think about it. What do even powers look like? So like, what does x squared look like? Parabola, right? So an even power should look like a parabola. The leading coefficient is the number in front, right? If the number in front is positive, then it's going to open up, right? If it's negative, it's going to open down. So these two pieces should just look like parabolas, but there's a major difference between these and parabolas. And that's the question mark in the middle. We actually don't know what the middle looks like. We just know that for any polynomial function, if our if our degree is even and the leading coefficient is positive, the ends look like a parabola that goes up. If the degree is even and the leading coefficient is negative, then the ends go down like a parabola does, right? The question mark is what we're going to have to go fill in. That's going to be the X-intercepts. That's going to be whether or not we bounce or touch. That's what we're going to have to do some work on.
Sound like sound waves or something.
Like what?
Sound waves or something. Radio waves.
Well, that'll be like sine functions, and that's when you get to pre-cal. Then you start studying things that are more connected to sound. Okay, so now odd functions. One of the odd functions from your toolbox was x cubed, right? And you remember what that looked like, right? It was down on the left, up on the right. So that's what this is going to be, down on the left, up on the right. In the middle, we won't know. And then if you change it to a negative in front of the x cubed, it's going to flip it over the x-axis. So it'll go up on the left and down on the right. So again, if you want to memorize a table, you can. You can actually create the table yourself if you just think through it a little bit. Right, so that's always going to be our first step when we go to graph a polynomial function. We're always going to just figure out what the left and right hand behavior is. The next challenge for us are to find the x-intercepts. If we can find the x-intercepts, we'll be able to fill in the middle, right? And the big question for us is going to be this, okay? If we can find the x-intercepts, is whether or not we cross through at that x-intercept or if we touch at the x-intercept. That's going to be our big, big question. So I would like to motivate this by showing you an example here. So I'd like for you to just look at this one. I'm going to write it up on the board here. The function is actually f of x is x to the fourth plus 6x cubed plus 9x squared. So if you just look at this right now, and if you were asked to try and sketch this, you could tell me the left and right hand behavior, right? What's the degree of this? What's n here? Fourth degree. And what's the leading coefficient? 1, all right? So with degrees, we're looking for even or odd. So this is an even degree. And for leading coefficient, we're going to look at either positive or negative, which is, in this case, positive. What happens when we have an even degree and a positive leading coefficient? Both sides go up, right? The middle, I don't know. So then we say, okay, well, what are the x-intercepts? Right, so that would be this is the leading coefficient test here, sorry. Leading coefficient test tells us this. What are the x-intercepts? Well, that means we have to set the function equal to 0, don't we? That's how we find x-intercepts for all functions. Set it to 0. So if I set this to 0, then you have to do what now? Factor, right? Factor. You can factor out a GCF, and x squared is common to all these, right? If I factor out x squared, then I'm left with x squared plus 6x plus 9, right? Can I go any further? Okay. This is x plus 3 times x plus 3, isn't it?
Yeah.
So could I write that like x squared times x plus 3, and instead of doing x plus 3 again, just put squared?
Yeah.
Okay, can you set those both equal to 0 for me, please?
X minus 3,
So you set x squared equal to 0, you just get 0, right? Take square root of both sides, you're done? On this one, x plus 3 squared equals 0. Again, take the square root of both sides, you still get 0, don't you?
Yeah.
So the answer here is x is negative 3. Look at the graph. Do I have x-intercepts at 0 and negative 3? Yes?
Yes.
Do I cross through or do I touch? I'm touching. I wonder how I'm going to be able to tell that I touch there from here. Is there something here that tells me I'm touching? Just leave it as an open question for right now, okay? Maybe there's something in this that tells me that I touch there. Maybe, we'll get to it. It's called the multiplicity, but hold on, I don't want to get ahead of ourselves. Let's just look real quickly at what we have so far if we were trying to sketch this. If I said draw this picture, here's what you could tell me. You know that it hits at negative 3. You know that it hits at 0, right? You know the left-hand behavior is what? That it does what? Goes up like that? Okay. So it goes up over here like this. I'm going to just do like this. And I'm going to say over here it does what? It goes up, right? Why is it not possible for me to like go up here and then come back down and then go back up?
Because you don't have another x-intercept.
That's right. I don't have another x-intercept. So this thing can never come back through and cross through the x-axis, or else I missed an x-intercept. So the left hand must go up here. The right-hand side must go up. So that looks like we might have enough information to graph it. And you may come in here and say, yeah, sure, this must just look like this then. But that's obviously not the case, right? It's that bouncing or that touching or crossing is the key to being able to get the accurate picture. So I still haven't answered how we're going to do it, right?
So,
Okay, stay tuned. It's about to happen. I'm going to show you. What I'm going to do...
This brief message is brought to you by.
What I'm going to do is this. I'm going to take a different function. So keep this all in mind. I'm going to take a slightly different function, which looks like this. F of x equals x cubed plus 6x squared plus 9x. What's the left and right hand behavior?
It's going to go down and up.
So the leading coefficient test, the degree here is 3, which is odd. The leading coefficient here is 1, which is positive, right? Which means down on the left, up on the right. In the middle, I don't know. And then I go look for my x-intercepts. So if I go get my x-intercepts, I set the function equal to 0 for x-intercepts. And I go through the factoring again. So I factor out an x here.
Yeah.
Does this look familiar?
It's the same thing. Same thing.
Just one little difference, right? Let's see, this is x plus 3 squared equals 0, right? What are my x-intercepts from here? If I set that to 0 and that to 0, what are my x-intercepts? 0 and -3. Those are the same x-intercepts that I just had, aren't they? Take a look at the picture. Do I cross through or do I touch? I'm touching where? At which one? At -3? I'm touching here. I'm put a T for touch. I'm touching at this one? Okay, and then at 0, what am I doing? I'm crossing through, right? Look at this one. And now, next to this, I'm going to put the one we just had before this. It was x squared, x plus 3 squared equals 0. We got two answers, 0 and -3. And I did what at both of these? I touched at both, right? Does anyone see what tells us whether or not we touch or cross?
Degree is positive or negative. I mean, odd or even.
If the degree of what?
The coefficient, the x.
Yes, you're on the right track.
X that you factored out?
Yes, this right here is called a factor, right? This x plus 3 is called a factor. This x right here is called a factor. This x plus 3 is called a factor. If the power on the factor is odd, you will cross through. So when I say power on the factor, I mean x is really x to what power? 1, right? If this power is odd, I'm going to cross through. What's the power on this factor? 2, even. And what do? I touch. Even touch, odd cross. Look at both of these powers here. Right? Touch, even. Here, even, right? Understand? It's the power of the factor that you're looking at, though. You are not looking at the number. The biggest mistake I see students make is that they'll look at this number and say, well, okay, 0 is even, so I'm going to touch. You're not looking at the number. This is your x-intercept. You're looking at the power on the factor. So the power on the factor has a special name. When you factor a polynomial, I'll write it out. The power of each factor is called the factor's multiplicity.
That was a very fancy name.
Yeah.
I thought it was a very fancy name.
Well, I think it comes from the idea that the factor is multiplied times itself, right? How many times is this factor multiplied times itself? Twice, so the multiplicity is 2. How many times is this factor multiplied times itself? Well, there's only one of them, so just one, right?
Just a question.
Yes.
On a test or a quiz, would you ever ask us to find the multiplicity of certain, like quadratic or polynomials?
Well,
Polynomials.
in graphing a polynomial function, you'll have to identify the multiplicity or else your graph's going to be off, right?
But it's not going to be directly asked, it's just something we're going to have.
Yeah, it's going to be indirectly asked. But I won't ask you to explicitly state the multiplicities. Okay? So our key to this, really for graphing polynomial functions, which are actually pretty nice, when it comes down to it, they're not so bad to graph, as long as you can factor them. If you can factor them, then it's just a matter of identifying the x-intercepts and determining if you touch or cross. All right? That's all it breaks down to.
So if we have to use the quadratic formula to factor, we're going to get to that.
If you use a quadratic formula, let's say you have something in here like this that you can't factor, right? Everyone pay attention to this. If you have a quadratic that you cannot factor, you can use a quadratic formula to get your x-intercepts, can't you? What are the multiplicities on those going to be? Think about it. 1. Because you know that this, you can't factor this, you're having trouble. But you know that it could only be 2 factors. Because this would have to be something x, right? X and x would be x squared. You couldn't have 3 factors or else this thing would be x cubed, wouldn't it? So if you ever have to use quadratic formula for solving the x-intercepts, you know that the multiplicity will be 1 for each one, and you will definitely cross through those. Good question. So today what we're going to continue to do here is we're actually going to graph some polynomial functions. Every single one of them we will be able to factor. Next class, we're going to start looking at polynomial functions that we can't factor, and I'm going to introduce you to a brand new technique for factoring. Okay? Yeah. It's a very powerful technique, actually. Yes?
You're probably going to explain this next, but
Uh-huh.
how do you know when the curve goes down?
Yeah, let's do one. Let's just do one from scratch, okay?
Yeah, that's a good question. I bet you left on that. That's great, you know, the x-intercepts. Yeah, well, how do you know?
That's precisely where the curves are.
Like, graduating from high school, we really know those 2 words.
That one's a little too hard.
So you gotta do it.
Negative, negative. I don't think so either.
That one's too
That's
low.
a test pro.
Trying to give you something that you can factor. There we go. That one's kind of boring though. Hold on. Let's make it degree 5. There we go. What happened? If this was looking good, then I messed something up. Hold on. X2, -3, -3, 0. That's what I want right there. Okay, let's sketch this. F of x equals x to the 5th minus 2x to the 4th
Minus 9x to the 3rd plus 18x to the 2nd.
All right, thank you, sir. All right, there it is. So we're asked to sketch this. All right, so first thing we're going to do, you know, we had a set of steps for parabolas. We kind of need to have a set of steps for this. The first thing I'll do is ask the question, is this a polynomial function?
Yes.
Yes. Do you remember me telling you, like, to always ask that first question, like, what am I looking at? Like, is it a parabola? Because if it's a parabola, you have a certain set of steps, right? If it's a polynomial, we have a different set of steps.
I don't think you ever explicitly said it, but it was kind of implied with like when we did like the different toolbox functions, I think.
No, when we did the quadratics, remember I said there was standard form and expanded form? In the first step for graphing those, I said, recognize that it's a parabola. Yes.
Is there any way that we could solve a quadratic more easily by looking at it as a polynomial instead?
Yes. Yes, once you see that new form of factoring.
Okay.
You might actually prefer it. You might actually get mad that they never showed it to you. But see, the thing is, you remember that formula I gave you, negative b over 2a to get the vertex?
Yeah.
Like that's pretty darn convenient for a parabola. We don't have nice formulas like that for just general polynomials. Yeah.
I like that formula.
Yeah, that's a nice formula. The problem is this, with a parabola, you always have a vertex with a parabola, right? And there's always only one of them.
Right.
And the way you get that vertex, there's only one way because there's only one that exists. But if you have a fifth degree polynomial, it may do something like that, and you may have several of them. And on other fifth degree polynomials, you may only have 2 of them, and there is even a possibility that you don't have any. And so there's no general easy way to get it, unfortunately. But you take calculus and then you realize that there is kind of an easy way to do it. And guess what it has to do with? The difference quotient. You have to do that difference quotient thing. All right, so it's a polynomial function. Next thing I'm going to do, I'm going to figure out what the end behavior is. I'm going to use the leading coefficient test real quick. So I'm following these steps right here. Make sure you're looking at a polynomial. I guess I'll change it to A, B, C, D instead. A, B, so it follows the notes. The leading coefficient test. So what is the degree of this polynomial? 5. And what are we looking at? If that number is odd or even, right? Odd or even. So this is odd. Okay, and then we look at the leading coefficient. That's the number in front of that, right? Which is 1. And that's a positive number. That's what we're looking for with leading coefficients.
So it's going to do this thing.
It's going to do this thing. Yep. So down on the left, question mark, up on the right. That's what we have so far. All right, so next we're going to find the X-intercepts. Where's my multiplicity step? Man, it's built in here. Okay.
I know it's pretty much asking the same thing, but similarly, will it help with like cubic ones? It's like where you go with x to the third, so it's like looking at it as polynomials with that new factoring method.
Yeah, the new factoring method is going to be very convenient for us. Yeah. Yeah. It'll work on most polynomials. Not all, though, unfortunately. Okay, so we have to set the function equal to 0. I promised you day 1 that factoring is something you need to know how to do and that it would never go away, right? Okay, I'm holding true to that promise.
In this case, do we separate them in 2?
How do you mean?
Like, one way of factoring was like 5 to the 5th.
Oh, like grouping?
Yes.
Yes, I do want to do grouping, but not till after I do GCF. Greatest common factor? X squared? Can I pull x squared out first? Remember, that's always what you want to try first is GCF. Now, it turns out it would have worked the other way also if you forgot the GCF, but it's a lot more dangerous to do it that way. And yeah, you can run into some issues if you forget to do something later. So there's my GCF, right? What's in the parentheses here is a cubic. And if it were quadratic, then we would do some method that we know. But it's cubic, which means in this case we have 1, 2, 3, 4 terms. When we see 4 terms in factoring, we try the grouping method. So this all just depends on how you learned it. You're supposed to split your 4 terms down the middle. Make sure you go to the left of that sign. And then what you're supposed to do is pull out of just these 2, you're supposed to pull a GCF. So let me do that on the next line. Do that right over here. And don't forget you still have that x squared out front, right?
Yeah.
So you have the x squared out front still. And I have a parentheses. I'm actually going to change it to a bracket because inside here I'm going to have another set of parentheses and I don't want to confuse them. So pull out an x squared from here. You're left with x squared and then in parentheses what? X minus 2. Okay, and then over here what you need to do is be able to pull something out here, right? A 9? Negative 9? You could do either one, right? But there's one that you have to do, right?
To match the,
What you have to have is this x minus 2 must match with what's over here. So you have to pull a negative 9 out. So if I pull a negative 9 out of these two, all right, negative 9, then x minus 2. We agree with that? That's your grouping, and then that's it. I can close that off. I'm done with the bracket, and then equals 0. So if those two match, right? If these two match, which they do, then I can proceed. If I can't get them to match, you can't proceed, right? That's what's going to happen next class. I'm going to give you a problem. You're going to try grouping. It's not going to work. But then I'm going to show you it actually still does factor. So make sure these match. And then what? What can I do?
Well, you're going to combine the x squared minus 9.
How do I put these together? X squared minus 9 times x minus 2? Or you could do x minus 2 times x squared minus 9. Either way, yes.
do we have to pay attention that the x squared minus 9 is different to squares in this one?
Yes, then we'll have to go an additional step. So let's do that. We have x squared here, bracket. The inside of this, you just told me, was x squared minus 9, and then x minus 2, like that, right? Now, do I really need the brackets anymore? No, because it used to have subtraction, so it was this minus this, but I've turned it into this times this. So everything's being multiplied, so you don't need the parentheses, the brackets anymore. Now this has always troubled me. I want to just visit this real quick because this has always bothered me, the way people learn this. I think almost all of you had looked at this right here. Almost all of you knew what the answer was from there. That was either x squared minus 9 in parentheses times x minus 2, or x minus 2 in parentheses times x squared minus 9 in parentheses. My question to you is why?
Because it's all multiplication.
How do you mean?
Meaning like you have to take the x squared times the x minus 2 and the x, and then that's minus, because that's implied that it's multiplying the 9 times the x minus 2.
I think he's asking why you only have one x minus 2 at the end.
You see 2 up there.
Yeah, like how does this turn into the, like how does that turn into that?
We were just
Oh,
told
meaning
that.
because
You were just told that?
That's what you said.
So let's do a quick vote, because I wouldn't be bringing this up if it weren't something that I notice every time I get through this. How many of you know that that turns into this just because that's what you were kind of told, and that's okay with you? Yes? That's okay with you? And it works, okay? And I'm not here to try and undo that.